class with me, Arun Sharma. And as you know, I am the author of the CAT books, of CAT series of books from McGraw-Hill Education. I'm also a plus trainer on Academy. I'm an IIM Bangalore alumnus, having passed out of IIM Bangalore in 1995. And after that, over the last 25 years, 2.5 decades, I've been focused on helping students prepare for this exam and prepare for aptitude. And all the work that I've done is around the same thing. And in this series of lessons, in these series of videos, I'm doing a discussion of previous year questions of the CAT, where we are looking at, not just CAT but also other exams, where we are looking at various questions and techniques and shortcuts of the actual exam and techniques and shortcuts of solving them. So here goes, without any ado, here goes the first question. I want you to solve each one of them and try to look at try to look at solving the question on your own first, and then we'll of course do a discussion of every question. So 20-30 seconds for you to digest the question. I'm not going to give you enough time to solve the whole question, but at least you have around 30 seconds to digest, 30-45 seconds to digest the question, and then I'll talk about the question per se with you. I'll talk about the solution with you and what are the best ways to think about solving this. So this question here that tells us that a lord got an order from a garment manufacturer for 480 denim shirts. He bought 12 sewing machines and appointed some expert tailors to do the job. However, many didn't report for duty. As a result, each of those who did had to stitch 32 more shirts than originally planned by Lord, with equal distribution of work. How many tailors had been appointed earlier and how many had not reported for work? Now again, if you remember the last question that we did yesterday, this question, where the process for solving this question was based on factor search of $200, $150, more than a factor search. Actually, it was actually a factor pair search, and that was the best way to solve this question, much faster than a normal solving of these questions, where you would end up using algebraic equations, complex algebraic equations, and take a long time to do it. So instead of that, this question was much more easily done by looking at, if you're looking at an option like for 200, we're looking at factor pairs of 200 and trying to see where the condition given the problem gets satisfied. So the problem gave us two conditions, that if he reduces the sticks per box by 25, he can fill 3 more boxes with the total number of sticks assigned to him. So that means you want 2 factor pairs for 200, where when you reduce one part of the product by 25, the other part of the product goes up by plus 3. And if you look through the factors of 200, you didn't find any of those happening. You had a drop of 25 on between a pair of factors, but it was not corresponding to a plus 3 increase. This was a plus 4 increase. So if the question had said that if he reduces the number of sticks per box by 25, he can fill 4 more boxes with the total number of sticks assigned to him, then this would have been the answer. So that's how we ended up finding the 50 into 3 and the 25 into 6 pairs. These two factor pairs where the condition given the problem that number of matchsticks is dropping by 25 and number of boxes is going up by 3. so that you are still filling the same number of matchsticks in the box. This is how this got structured or solved. And this approach, in general, is a very important approach for CAT problem solving and for generally aptitude problem solving. And you can see this happening again in this question. If you look at this question, the question says, a lord got an order from a garment manufacturer for 480 denim shirts. And he bought 12 sewing machines and appointed some expert tailors to do the job. So, however, many didn't report for duty. As a result, each of those who did had to stitch 32 more shirts than originally planned by Lord. So, number of people original into number of shirts per person is replaced by number of people new into number of shirts per person. This is the new number of shirts per person. And the only thing the problem tells you is that there's a growth of 32 when you go from here to here. There's a growth of 32 shirts because each person had to stitch 32 shirts extra than originally planned. So, a simple solution to this question, rather than again going through what you can describe as algebraic processes, instead of that, a simple solution to this question will again be factor pairs. So, 480 factor pairs for 480 are 1 480, 2 240, 3 160, 4 120, 5 96, 680, 7 does not divide it, 860, 1048, 1240, 13 does not divide it, 14 does not divide it, 1532, 1630, 17 does not divide it, 18 does not divide it, 19 does not divide 480. And when you do these searches, your search has to be such that you only search up to the square root of 480. So square root of 480 being 21 point something, you only have to look till 21. So 2024 becomes the next factor pair. And if you look through these factors, these factor pairs that you have, and you try to see where you're getting your amongst these factor pairs, where you're going to get your difference of 38 between two factors. So you will be able to see, if you go down on this number, you'll be able to see that the difference of 32 exists only between 48 and 80. There's no other pair of factors on which you have 48, you have a difference of 32 between two factors. No other place. And hence you realize that the only value at which something like this is feasible, 32 more shirts every person had to fit in or make, can only be feasible with 80 and 48. That means originally everybody was making 48 shirts, and hence there were 10 people in the group, and everybody was making 48 shirts. And now there are 6 people in the group, and everybody is making 80 shirts. So how many people were there originally? Answer is 10. And how many did not turn up? So 6 have turned up. So 4 did not turn up. So 10 4. Option C is the right answer here. Right? So this tells us two repeated questions. Tell us that factor search based questions are very important in uh, or factor search skills are very important in number systems. In fact, throughout maths. So that's the next question for you now. And this is a count, so it's a question between number systems uh, and you can call it permutation combination. And the question says how many three-digit even numbers can you form such that if one of the digits is 5, the following digit must be 7. So you need to be careful with a question like this. The question is asking us two things. One is it is specifically talking about three-digit even numbers, right? So and there's another condition that if one digit is 5, the following digit must be 7. But this condition, one digit is 5, the following digit must be 7, is not a necessarily binding condition for this question. So, for example, if I talk about a number 100, there's nothing in this question that stops me from taking 100, right? Or 102 for that matter. The only thing it stops me from is I can't take a 150, because if one digit is 5, the next digit should be 7. So if I go through this and think about in the hundreds, how many numbers do I have which have this property? I can see that numbers starting with 1, in the second digit, I can put anything between 0, 1, 2, 3, 4, 6, 7, 8 and 9. I can't put a 5 there. So there are 9 ways of filling this digit. And once I fill this digit with any of these 9 numbers, my last digit or my last number can only get filled with 2, 4, 6, 8, 10. 2, 4, 6, 8 or 0. So I can make out that in the hundreds I have 45 such numbers. 9 into 5. The 9 into 5 logic comes from that I can fill the second place in 9 ways and I can fill the third place in 5 ways. So there are going to be a total of 45 numbers that have this property in the hundreds. Now the 200s is going to be no different. There will be 45 numbers there also. So if we start consolidating our count, what we'll get is that in the hundreds, the 200s, the 300s, the 400s, the 600s, the 700s, the 800s, and the 900s. There will be 45 numbers each in each of these zones or in each of these ranges of numbers. So this is going to give me a total of 45 into 8, 360 such numbers. And then I also need to make sure that I don't forget to count the numbers in the 570s which have this property that if one of the digits is 5, the next digit should be 7. So my ending digits can only be 2, 4, 6, 0 to 4, 6 or 8. So I can have 5 numbers which in the 500s which are in the 570s. Because if I'm going to the 500s, I can't go to the 510s or the 520s based on this question. 520s is not allowed. or 510s is not allowed here. And hence in the 500s, only the 570s are alive for me. And there are 5 numbers there. So 360 numbers here, 5 numbers there. So the total is 365, and hence option C is the correct option answer here. Right? So let's have a look at the next question then. It's actually a series of questions actually. Right, so this is the question for you, the third one. This question says there are 50 integers a1, a2, a3 up to a50. Not all of them necessarily different. Let the greatest of these integers be referred to as g and the smallest integer be referred to as L. The integers a1 to a24 form sequence S1. These form sequence S1 and the rest form sequence S2. So A25 to A50 is forming a sequence S2. And the question further says that each member of S1 is less than or equal to each member of S2. So every member of S1 is less than equal to every member of S2. This is the information. Right? So the first question says if we change the values, the sign of all the values in S1 while those in S2 remain unchanged, which of the following statements is true? So we can to understand what's happening here, we can just imagine, first of all, I can imagine a thought process where I'm saying that my first 24 numbers are 1 to 24. And because each number in S2 is larger than every number in S1, my S2 numbers are 25, 26 up to 50. My S1 numbers are 1 to 24 and my S2 numbers are 25 to 50. So in this scenario, if I do what this question tells me here to do, change the sign of all the values in S1. If I do that, S1 will become -1, -2 up to -24. So which of the following statements is true? Now of course, this is just one possibility of what can happen for S1 and S2. There are many more possibilities. But when you're talking about a question like this, in which the question says which of the following statements is true, specifically, is asking you which of the following statements is true, then if the statement is true, it has to be true for every feasible case, every feasible possibilities of the values of S1 to S2. So only then can you call the statement true. Otherwise, if you're making a statement which is not false, which is not true in one specific case, then that question will obviously be I mean that conclusion as true can't be taken by you. So if I'll give you a small example of this. Suppose I say that Amit is a good boy. Right, now this is a statement which, if I want this to be true, Amit has to be a good boy always. So if Amit is actually a bad boy for 2 days of his life, or he is a bad boy every Sunday, then I can't corroborate the statement, or I cannot justify the statement to be true all the time. So for something to be true, it has to be true under all possibilities. It cannot be untrue in a couple of possibilities and true in 99% cases. So that's why in such questions, if you even if you have a simple process that you take, okay, just one केस में ये ट्रू नहीं है तो कभी ट्रू नहीं होगा. So if I, for example, if so with these numbers in S1 and those numbers in S2 based on the information given to me, if I change the sign of every number in S1, the numbers in S1 will become this, and S2 we are keeping unchanged. So in this case, if I test option 1, option A, every member of S1 is greater than or equal to every member of S2. That's not happening. If it does not happen in this one possibility, it cannot be a blanket true statement. It will have to be qualified true. It can be true, maybe true, can be false, but it can't be a true statement. So this is not going to happen. So option A is rejected because in this specific case that we checked, every member in S1 is greater than or equal to every member in S2 is not happening. Statement B says, if I change the sign of every number in S1 and keep the signs unchanged in S2, the statement B says that G is in S1. G was the largest number in the group of A1 to A50. So G is in S1. This is not going to happen again because G is going to remain this number, the largest number of the S2 group. So this option also goes away because I have found one case in which this is not working, and if I can find one case in which it is not working, then that option or that statement cannot be true. Right? So third statement, if all numbers in S1 and S2 had the same sign. Now in this case, I have actually had the same sign in S1 and S2. Then after the change of sign, the largest number in S1 and S2 will be in S1. Now S1 and S2, after you change the sign of S1 and make the numbers -1 to -25, the largest number will still be in S2, not in S1. And hence, the correct answer to this question is going to be D, which is none of the above. Right? Now this is a series of 3 questions. In this case, series of 3 questions actually. So let's look at the second question here. And the question says elements of S1 are in ascending order. Okay, so this justifies this obeys my 1 to 24 for elements in S1, and those of S2 are in descending order. So this will change. In the previous case, we had written 24 to 50, 25 to 50 for S2. But because S2 is in descending order, A25 will have to be the largest number of S2. And this is going to go all the way to 25. And A50 is 25. So elements in S1 are in ascending order, those of S2 are in descending order. A24 and A25 interchanged. A24 and A25 interchanged. So what's happening is you're taking this away from here and taking this away from here. So 50 comes here and 24 comes here. That's interchanging. Then which of the following is true? S1 continues to be in ascending order. Yes, definitely. इस केस में तो हो रहा है. S2 continues to be in descending order. No, because I found one case where it is not in descending order, so that's good enough. S1 continues to be in ascending order and S2 in descending order. C is also wrong because S2 is not in descending order. And D is none of these. So very clearly, option A is the right answer here. Because you can also think that if you change these numbers, given the fact that every number in S2 is larger than every member of S1, when you rejiggle or rejig S2 to write the largest number first, it's not going to change the fact that every number in S1 in this scenario, and S2 is this way, and then S2 is descending order, and then A24 and A25 are interchanged. So whatever you do when you take one number from here and put it there, and you take one number from here and put it there, whatever you do in this case, whatever you do in this case, your values in S1 are going to continue remaining in ascending order because the number coming from here is going to be larger than all the other numbers that are already in S1. So that's the reason why this will never be contravened, option A. Right? And option B, of course, we saw the one case that we took up, and that option B is no longer in descending order because the 50 got replaced by 24. So this option B cannot be, may be true, but it's not true definitely in this case. Right? In fact, if you analyze correctly, you'll see that it can never be true actually. So one last question for today. Third question in this. In this set, and this question is: every element of S1 is made greater than or equal to every element of S2 by adding to each integer of S1 and integer x. So what's happening here? In the case we took, S1 was these numbers, S2 was these numbers, and if I'm going to make each member of S1, and G is the largest number in S2, L is the largest number in S1. If I'm going to make each number of S1 greater than S2 by adding some number, that number greater than or equal to. So I can clearly see that in this scenario, I'll have to use a minimum value of 49 for what I add, because only then will 1 become 50. Only then does 1 become 50. So in this situation, you're adding 49 to get there. So, and 49 also represents the difference between G and L. And you can see that 210 actually does not make any sense here. And smallest value of S2, you can't just add 25 and make every element of X of S1 greater than S2. The largest value of S2, 50, this will definitely do it. But the question is X cannot be less than. So with 50, with adding 50, I can still make this happen. But then the value of X can also be less than 50 at 49. In this scenario, it does not, it works perfectly, and hence the correct answer is option D, which is G minus L. So right, so that's it for today. I'll be back soon with more sessions on this. Just a small reminder: Unacademy Plus is a platform which is almost one of the unique academic startups in the country, where it gives you the hand, the remote, in terms of which educator and which course do you want to use to get yourself through the competition you're preparing for. And Unacademy Plus has come up with a subscription model. Under the subscription model of Unacademy Plus, once you subscribe for a certain period of time, 1 month, 3 months, 6 months, or 12 months, once you subscribe for a certain period of time, you have access to all the courses and of all the educators there, live as well as recorded. And if you do decide to take up an Academy Plus, please use my promo code Arun M Sharma. This promo code will give you a 10% discount over the existing discounted fees. And I hope to see you. I'm one of the teachers. I'm one of the Plus educators on Academy Plus, and I hope to see you. I'm going to start my CAT 20 lessons on data interpretation, logical reasoning, and other things very soon with you on Academy Plus. So look forward to having you in my classes there. And good luck and goodbye, everyone. For the time being, Arun Sharma signing off. Bye bye.